We are being recorded. I'm going to take rolly roll. Here we go. Rolly roll time. Let's get this quick. 10:46. Short day. Sort of short. It's like a normal day, except just end quicker. Donnell.
Yo.
Sick. Ishi. Madison.
Here.
Hila. John. Alex. John Travola. Alex Garcia.
Here.
Jasmine Godinez.
Here.
Matthew Gonzalez.
Here.
Brandon Grijalva.
Here.
Bella Hanone.
Here.
Joshua Hernandez.
Here.
Monica Hulkamp.
Here.
Jones. Gracie Marcelo.
Here.
Carlos Origel.
Here.
Jose Orozco.
Here.
Ethan Ramos.
Here.
Natalie Rodarte.
Here.
Jaylene Ruiz.
Here.
Giovanna Ruiz.
Here.
Taylor Simmons. Jay Singh.
Here.
Gianna May Teco.
Here.
Jacob Terrell.
Here.
Roberto Valdez.
Here.
Ariana Villalobos Castillo.
Hi.
Isaac. Okay, here's who I have absent. Isaac Aquino, Ishi Blanco, Kayla Bradley, John Chavola, Eric Jones, Taylor Simmons. Isaac Aquino. Ishi Blanco.
Here.
Kayla Bradley.
Here.
A word cannot have three of the
John
same
Chavola.
Here.
And Eric Jones. Taylor Simmons.
She's here. She's just having trouble getting on right now.
Okay. Okay, so I have Isaac Aquino and Eric Jones absent. And Taylor Simmons having a hard time getting on. So is Taylor here? I don't even see her. Oh, I'm marking Taylor absent because I don't see her. When she comes on, she just should let me know. Taylor is absent. Taylor, if you get on, let me know.
I'm here.
You're here, okay. Okay. All right. Actually, I should have checked the chat. I didn't check the chat, Taylor. I should have done that. Okay. I don't know if you said you're here on the chat. All right. Today's a minimum day. Tomorrow's Friday. What I'm going to try to do is get, if you look at, okay, don't be confused by this. When I say don't be confused, that means it's going to be confusing. Okay. Okay, here's what I'm doing today. Today's assignment is 362, 3 through 29 odd. Check your understanding. By the way, a lot of people are not doing their check your understandings. I'm giving you a 0. Make sure you've done all of your check your understandings. That's on you. Some people haven't even taken the test. You get a 0 if you don't take the test. Yesterday's test. So check to make sure you did all the check your understandings. There's a check your understanding today. Make sure you do those. Okay. Now, tomorrow is the same page, 362, but we do 31 through 55 odd. I'm going to try to cover all of this today. So tomorrow we can have, like, I just say if there's any questions or something like that, have a mellow day tomorrow, okay? So that's my goal. That's what we did in last class. It was a lot of stuff, but we got through it, okay? Are there any questions? Okay. So here's our assignment. All right. Assignment number 51, we're doing 7.1, defining and using sequences. Page 362, 3 through 29 odd. I'll give you a second to write that out. Okay. So number 3 asks us this question. Let's look at number 3 here. Where are you? Number 3. Okay, here's number 3. Hey, do your push-ups. Make sure you exercise every day. Okay, number 3. Compare sequences and series. Sequences and series. Okay, compare sequences and series. Okay, so I have this all written down, and I'll explain it to you. Okay, a sequence is an ordered list of numbers. That's what a sequence is. So example, 3, 5, 7, 9. You can see I'm increasing each of, there's a pattern, right? I'm increasing those by 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. That's a sequence. So go and write that down. That's number 3. Okay, series is the sum of the terms. So series is where you basically just add these up. 3 plus 5 plus 7 plus 9. That's a series. So go ahead and write that down. Okay, can I move on? That's number 3. So sequences and series. So that's what it's all about. Basically,
What's that
we're
last
talking
word?
about pattern. Terms, T-E-R-M-S. Terms, T-E-R-M-S. So basically, we're talking about patterns this chapter. Defining sequences, when we go defining and using sequences, we're going to be talking about patterns. Adding patterns, subtracting patterns, multiplying patterns, da, 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 da. Okay. I'm gonna get rid of this in 10 seconds. 5, 4, 3, 2, 1. Okay. Look, I'm running out of paper, running out of paper. Let's do number 5. Flinky, flinky. Flinky, 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 flinky. Okay. 5 says, in exercise 5 through 14, write the first 6 terms of the sequence. Okay. That's pretty straightforward. I know it doesn't seem like it, but let me show you. Let's first go, our sequence is a to the n equals n plus 2. So they want the first 6 terms. Okay, well, no problem. So let's do a table so that we can see what's going on here. Think. First 6 terms. So we have n here. Since we use a to the n, we're going to put an n right there. So the first 6 terms, let's call the first term number 1. Let's call the second term number 2. Let's call the third term number 3. Let's call the fourth term number 4. And then this is going to be n plus 2. What are my first 6 terms? Well, if this is n, this tells me to add 2 to my n, so my first term is 3. My second term is 4. My third term is 5. Any questions on how I'm getting those numbers? 3, 4, 5, 6, 7, 8. Those are your first 6 terms. That's your answer. 3, 4, 5, 6, 7, 8. That's all you got to do. Now we can do a. Are there any questions? Can I move on? I'm going to do 13. Actually, I'm going to have you guys do 13 with me. 13 says f of n instead of n is equal to 2 times n over n plus 2. Okay, so let's do our table. First 6 terms. First term is number 1. Second term is number 2. Third term is number 3. Fourth term is number 4, 5, and 6. Okay, I'm going to do the first one. I'm going to have you guys do I'm going to have some of you do 2 through 6. So the first term, what this is telling me is I take my equation. I'm going to write it here. 2 to the n over n plus 2. It says my first term says I replace it with n. So 2 times 1 over 1 plus 2. 2 times 1 is 2. 1 plus 2 is 3. So my first term is 2/3. My second term, you plug in 2. Okay, so plug in 2. 2 times 2, 2 plus 2. Okay, so here I'm going to ask. All right, my second term, okay. So let's go with, okay, Jaylyn.
Yeah.
You're going to do the second term. Jasmine, you're going to do the third term. Jeshua, fourth term. John, fifth term. And Jose, sixth term. Okay, you guys, and everyone else, plug in some terms, see if you can get it, okay?
Can you go back
Jaylyn,
to
I'm gonna
your
get to you
screen
in about.
before? I was still writing what you had down.
No problemo. Oh, ha, 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 ha. Ha, 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 ha. Okay. Jalen, are you ready?
Yeah.
Okay. What'd you get for the second term?
I got 4/4 or 1.
Very good. Now, let me get my notes here. Okay. Who's next? Jasmine, what'd you get for the third term? Jasmine. Jasmine, are you there?
I don't think she is, because earlier she said like her screen froze. So I think it's her Wi-Fi acting up again.
Jeshua, what's the fourth term?
4/3.
That's correct. John, fifth term.
I got 1 and 3/7.
Yep. I'm gonna write it as 10/7. Very good. Just leave it like that. Okay, Jose, what'd you get? Yes, simplify it.
3/2.
Very good. Jasmine.
She said her thing isn't working right now.
Did you send it in the chat?
No, she just told me.
Oh man, I can't see it. What did she write in the chat? Let's see. My screen is frozen, or is it just me, or do we simplify? Simplify or no? Yes, Jose, we got that. All right, anyway, the third term is, since we are, actually, let me get to screen sharing mode. Jasmine, are you there? Can't even.
Hello? Is it
Oh,
working?
there you are. Did you get the third term by any chance?
Can I see the?
No,
Can I
that's
see
all right.
the?
I got it. I got it. Okay, we have here 2 times 3, right? We plug in 3 for our n, and then 3 plus 2. 2 times 3 is 6. 3 plus 2 is 5, so it's 6/5. And those are the first 6 terms. 2/3, 1, 6/5, 4/3, 10/7, and 3/2. Sorry, I don't know why I wrote them different, but all right. That's the first part. Find the first 6 terms. Okay, now the second part, okay, we get kind of crazy here. We're gonna have to learn how to, on number 15. Okay, so here's 15. We have to determine the pattern here. Now, there's a couple of patterns that we must follow. There's 2 types that we're mostly going to focus on. Sorry if you can't read my handwriting. I'm going to read this to you. There's the arithmetic, arithmetic, arithmetic series. That's an I, believe it or not. That's a horrible I. Series. I'll just put that there. Makes it a little bit more like an I. And that R's, my R's are terrible. Okay, so an arithmetic series is linear. Linear. Arithmetic series is linear. And it increases through addition. Increases through addition. Okay, so make sure you have that written down. So look at the pattern here. I'm going to tell you, is this arithmetic or geometric? The other one is geometric series. It is exponential. This increases through multiplication. Okay, I'll show you what I mean by that in a second. Go ahead and write that down. Okay, I'm going to get rid of this in 10 seconds. Okay, 5, 4, 3, 2, 1. Okay. So in number 15, it says, in exercises 15 through 16, describe the pattern. Is it arithmetic or geometric? Write the next term and write a rule for the nth term. Okay, so this is 1, 6, 11, 16. What's the next term and what's the rule? The rule goes like this. Like going back to number 5, which is an easier one. My rule was n plus 2. Whatever I do to this, I get this, right? 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. Blah, 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 blah. This one was, the rule was 2n over n plus 2. 2 times 1, n plus 1 plus 2, right? Okay, so it's whatever I do to this to make it that. What do I do to this to make it that? What do I do to this to make it that? What do I do to this to make it that? I add 2 to 4 to make it 6. I add 2 to 5, right? The rule is whatever you do to this top number to make it the bottom number. Okay, so this goes here. And this goes here. So what are we on? We're on 15, I think, right? So 15, our pattern is 15. Our pattern is, we start with 1. Oh, not like that. Where my pens go? Start with 1. Then I have 6. Then I have 11. Then I have 16. Okay? So the first thing says is describe the pattern. Well, before I do all this, what I'm going to do is I'm going to make it on a table. Flink, 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 flink. First term, second term, third term, fourth term. Okay, the first term is 1, because that's my first term. My second term is 6. That's my second term. My third term is 11. And my fourth term is 16. It says find the next term, which will be 5. Okay, so before we do that, let's answer the first question. Am I going too fast for anyone? Describe the pattern. Now, is this arithmetic or geometric? Is how we're going to describe it. Let's go back to our definitions. Arithmetic is linear, increases through addition. So what am I doing? I go from 1 to 6. Then I go from 6 to 11. Then I go from 11 to 16. How am I increasing? Through multiplication or addition?
Addition.
Very good. And I'm adding what? 5, right? Okay, see that? Okay, see that? That's arithmetic. It's an arithmetic sequence. And it's linear. Because I increase by 5 consistently by addition, it's linear. So here's the question that's kind of confusing. How do I make 1 into 1? How do I make 2 into 6? How do I make 3 into 11? How do I make 4 into 16? That's the rule. Okay? Now, if I'm consistently adding 5 like that, my rule is going to be 5 times n. Don't fall asleep on this. I know you're falling asleep. Wake up! Wake up! Don't fall asleep. This is important. This concept right here. So I'm saying 5 times. Wake up! Sorry, my big old nose. Now, this is 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, not 11. 5 times 4 is 20, not 6. Let's look at this one. 5 times 1 is equal to 5. How do I change 5 into 1 through addition or subtraction? I take away 4. 5 take away 4 is equal to 1. So my pattern is 5n take away 4. It should work for all of them. 5 times 2 is 10. Take away 4 is 6. 5 times 3 is 11. Right? It should work. 5 times 2 minus 4 is 10. Take away 4 is 6. 5 times 3, take away 4. 15 take away 4 is 11. Boom, 11. Sorry, I'm writing it out right there. Boom, 11. So let's figure out the fifth term. 5 times 5 is 25. Fifth term, 5 take away 4 is 21. That's your fifth term. And that's it. Okay, I'm going to do one more of these problems 15 through 25. This is actually today's homework. I'm going to do 23. Okay, let's look at 23, and then we'll move on to a new concept. It's a little bit more difficult, this one, because with the fractions. My first term in the series is 2/3. My second is 2/6. My third is 2/9. Because they get real weird patterns here. If you have trouble with these patterns, you can look at the solutions to help give you a little boost. You got to keep looking at these patterns to help you understand this. So there's solutions that'll help you to figure these out. You have my permission. Just make sure you understand what's going on before you just look at the solutions and just be, oh, that's the answer. Make sure you understand why, and then ask me tomorrow. Okay, so here are my series. I'm going to go like this, which I think class gets out at 11:46. We have this as, how's this listed as? This 23. And okay, so my first term, my second term, my third term, my fourth term. My first term is 2/3. My second term is 2/6. My third term is 2/9. My fourth term is 2/12. This one is neither arithmetic nor is it geometric. Because I'm not adding to like 2/3. What? I mean, I'm adding the denominator. What the heck? How do you add to the denominator? I've never seen where you can just add and increase the denominator. 2/3 to 2/6 to 2/9. It's a weird pattern. That's why I'm doing this one. Okay, so what do I do to 1 to make it 2/3? What do I do to 2 to make it 2/6? What do I do to 3 to make it 2/9? What do I do to 4 to make it 2/12? Okay. 3. Let's just look at the denominators. What do I do to 1 to make it 3? What do I do to 2 to make it 6? What do I do to 3 to make it 9? 4 to make it 12? Does anyone see my pattern? I'm looking at you guys. Actually, I'll do this again. 1, 3, 2. How do I make 2 into 6?
Add
3 into... add 3 this way. But the 1 to the 3 and the 2 to the 6.
Multiply 3.
Multiply by 3. Yeah. And you're right. When you say add 3, look this way. We want to look from n to this number. So here's the pattern. It's really weird. Notice the 2 stays the same. It's 2 over 3 times n. You multiply the denominator 2/3 by the n, which is weird. It's a weird pattern. So 2 over 3n. That means the 5th term would be 2 over 3 times 5, which is 2/15. Anyway, that's 23. I'm going to move on. I'm going to get rid of this in 10 seconds unless there's any questions. So I did pretty much everything for today's. I'm going to go into tomorrow's assignment. You can do it on the same page or do it on another one if you want. Okay, so there's something called summation notation. Summation notation. Okay, I'm going to give it to you right here. Write this out. Summation notation. Okay, just write it out. We don't understand what the heck is going on here yet. You're all, what the heck is he talking about? That's right. You've never seen, well, maybe some of you have seen it. But summation notation is going to help us to figure out the sequence. Remember, the sequence is where you add them. I'm sorry, the series. The series is where you add them up. So summation notation, put a big old E-looking thing. That thing is called a sigma. It's Greek. We're talking Greek here. Can't understand what you're saying, Sensei. You're speaking Greek.
Mr. Sanchez, what did you write under the 1?
Yeah, so I'm going to explain that in just a second. So we're going to write I equals 1. This is the index, is the I. We call it that. I'll explain what that is in just a second. The I is the starting point. So what I mean by that is if we take our problem number 1, so this is starting point, Jay. Starting point. It's where we
Okay,
start
thank you.
at. And the n is the stopping point. It's where we stop. And the x squared is the element. Okay, so if I was to look at number 5 here, my starting point is 1. Could start at the n equals 1, so our starting point is 1. My ending point is 6. We ended at the 6th term. Starting point is the 1st term. The ending point is the 6th term. And this is the element, n plus 2. So you put an n plus 2 here. Now, what this E means is I want to find the 1st term, the 2nd term, the 3rd term, the 4th term, the 5th term, all the way up to whatever n is. Notice it's called summation notation. What do you think when you hear the word summation? What does that mean? Summation. Let's see. When you hear the word summation, Eric Jones, what do you think with summation? What does that mean to you?
I don't know. Nothing really comes to mind.
SUM. You ever heard the term SUM?
Addition.
Yeah, it means addition. It means when we see this, it means we add them all together. We're adding them all up. Okay, so that's what that means. Okay, so using that summation notation, let's look at number 31. Let's look at number 31. Okay, 31 says, where are we? Oh, here we are. Write the series using summation notation. Remember, the series is where we add them. So tell us the series is 7 plus 10 plus 13 plus 16 plus 19. Now, so that we can see it, I'm going to write it as a table. My first term is 7. My second term is 10. My third term is 13. My fourth term is 16. My fifth term is 19. And I'm adding them all up. It means I use summation notation. So we have to figure out the equation here. What am I doing? I'm adding 3. So that means it's arithmetic. It is linear. Actually, with summation notation, it changes n into an I. It's going to be an I now. Make it an I because it's summation notation. Okay, I'm adding 3. What does that mean with my equation? Anyone know? What do I need to do? If I'm adding 3, we did it on, what problem was that? On number 15. What do I do with the 5? Yes! We say 3 times I, or 3 times n before, right? Now, 3 times 1 is 3. How do I make 3 into 7? You add 4. I don't know if you guys are paying attention or not. 3i plus 4. Any questions on how I got that 3i plus 4? Okay, I got to see if you guys are alive. Jose's correct. Okay. All right. Taylor, do you understand what's going on?
Yeah.
Okay. Gianna, do you understand what's going on?
Yeah, everything's just lagging right now.
On my end?
No, for
Jay,
me.
am I? Okay. Well, stop and ask questions if you need. Jay, do you understand?
Yeah.
Am I lagging?
No, not for me.
Okay, Roberto, how are you doing?
I'm doing fine.
Okay, great. I'm moving on then. Sounds like we're doing good. I just want to see if you guys were alive. Do we know who our president is yet? I don't. Okay, here we go. Now, but that's it. We have to write our summation notation. So let's do our big sigma. Sigma. My starting term, I start with 1. I equals 1. My last term is 5. And I'm adding them all up. My index is this. 3i plus 4. That tells me to do this, right? 7 plus 10 plus 13. That's your answer. That's 31. How are we doing on time? We have about 20 minutes. I'm trying to finish this quickly. That's the easier one. I could do a more difficult one if you want to stay after class. But that's the basic idea. You can use the, again, use the solutions to help you understand this. Number 39. Okay. It says find the sum. Okay, now okay. I'm going to do a couple of these very quickly. 39 is, okay, find the sum. So now they give us summation notation. Some of these are easy, some of these are more difficult. But 39, let's make a table. It says summation, sum, 2i. I start off with the first term. I end with the sixth term. So I'm going to do a table. Do you need to do a table every time? No, but I think as a teacher, it makes it easier for me to show you what's going on. And as you're learning, it'll be easier for you to see what's going on. First term, second term, third term, fourth term, fifth term, sixth term. So this tells me I plug in 1 to 2i. 2 times 1 is 2. The next term is 2 times 2 is 4. Then I plug in 3. 2 times 3 is 6. 8, 10, 12. Those are my terms. But the answer is not that. This tells us to add them all up. So you want to say 2 plus 4 plus 6 plus 8 plus 10 plus 12. And your final answer is going to be, add them up, is 42. That's how you use summation notation. This tells me what I start with, the first term. This tells me what I end with, the sixth term. This tells me what to do with my terms. Multiply it by 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Blah, 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 blah. This summation tells me to add them all up. So my answer is 42. I'm going so fast. We're almost done here, though. Now, there is a pattern. It's called the formula of special series. Actually, I'm going to get rid of this in 10 seconds unless someone needs it. 5, 4, 3, 2, 1. Okay. Now, these are going to make your life a heck of a lot easier. These little patterns here. Formula of special series. Go ahead and write this down, and then I'll explain what they mean in just a second. The sum of n terms. Okay? So if you're just adding n terms, this means you start with 1, we end with n, but I have a constant number here. Okay? So this one, well, is a little bit because it's just going to be whatever n is. Summation of this says it's just going to be that number. It's just going to be 1. It'll be n. Okay, whatever n is, the summation, no matter if you add them all up, it'll be n. And I'll explain that when we do problems. So just write this down. Okay, next is sum of n positive integers. So now, if it's just I, and I'm not doing any, if it's just I, like whatever the I is, if it's just I, and I'm just adding those numbers up, shortcut, and I'll explain what this means in a second, just write it down, is n times n plus 1 divided by 2, where the n is this number here, the last number. Okay, then the last one, okay, let's just say I'm squaring my term, right? Just square it. Okay? And then I add them up. The final answer will be n times n plus 1 times 2n plus 1 divided by 6. Okay, so go ahead and write that down. And again, I know you're thinking, you're all, what the heck is he talking about? This makes no sense whatsoever. Let me show you a problem, and it'll make a heck of a lot more sense. In fact, you would rather do this than actually just adding all that crap up. All of it up. Again, we're starting tomorrow's homework. So since it's just all the same chapter, I just thought I'd do it all at once. Hopefully you'll appreciate this tomorrow. Okay, I'm going to get rid of this in 10 seconds. I'm going to explain how we do this in number 49. Five, 4, 3, 2, 1. Okay. So let's look at number 49. Okay, I'm just going to write it out, not look at the problem. It says, what is summation of, we start with actually, it won't work with 49. Start with the 16th term. Actually, I can't. Man, my eyes are so bad. I have to look at my. Start with the 10th term. And then we go to the 25th term. And we have I. Okay. Actually, this one we don't need to use the pattern for this one because it starts at the 10th term, so we can't use the pattern. But let's see what this means. 49. We have here I. And then this is also I. So all this is saying is we're just going, right? We start with the 10th term, the 10, and we say I equals, right? It's like saying plug in for I is 10. It's just 10, right? It's not doing anything to it. It's just I. So we have 11 is 11, 12 is 12, all the way up to 25 is 25. So we just go 10 plus 11 plus 12 plus 13 plus 14 plus 18 plus 19. So that's 49. Let me see something here, though. So you're going to add those up. So I'm looking some up here. I think you just got to add them up. I think that's the only way to do that. I'm double checking, though. Oh, no. Oh. Oh, okay.
What
Actually,
question?
Yeah.
What question number is this?
49. Okay, actually, what we're going to use here, instead of adding all those up, actually, this is cool. We're going to use, because see this pattern here? We're going to use the sum of positive integers, which is this. What you guys have is I equals 1, n, I, where we go n times n plus 1 all over 2. Okay? So instead of adding all those up, okay, how do I explain this? Let's figure out the series, but this tells us from 1 until n, right? So, but we're going from, not from 1 to 25, we're going from 10 to 25. Okay, so let's figure out 1 to 25 first. So to figure out 1 to 25, let's see, we're going to go like this. This is adding 1 to 25 will be this. N, can I fit this? 1 to 25 will be this. N is 25, so we say, write it here. Oh, I'm trying to fit it all. Well, here's my, I'll write it here. So I'll rewrite this. I equals 10, 25, I. Okay. So 1 to 25 will just be this. Plug in, instead of going 1 plus 2 plus 3 plus 4 plus all the way to 25, we say we plug in 25 times 25 plus 1 all over 2. Well, that'll get me from adding 1 plus 2 plus 3 all the way up to 25. I don't want 1 to 25. So let's subtract. Let's subtract 1 to 9, right? So let's subtract. So basically, subtract 1 to 9, which will be this. 1 to 9i. So I'm going to subtract 9 minus 9 plus 1 all over 2. So instead of adding all those up, you just go 25 times 26 divided by 2. I don't have my calculator. 25 times 26 divided by 2. (25 times 26 equals divided by 2). 325. Subtract. Well, we don't need the 1 to 9, so let's subtract the 1 to 9. 9 times 10 divided by 2, which is 90 divided by 2 is 45. And 325 minus 45 is 280. Yeah, 280. So what did I do? I took the sum to 25, and then I subtracted the sum to 9, since I don't only need the sum to 10. All right, are there any questions? I want to try to get through one more. I can go over this one again tomorrow if this was confusing. I got one more. Let's do number 50 here, even though it's not an odd problem. It's the n squared, and it goes up to 18. So I'll just do that real quick. That'll help us understand the sum 50. Let's get a new piece of paper. Here we go. 50 is the summation. Let me get it here. The summation starting at 1. This one's more straightforward. All the way to 18 and then n squared. Okay, so instead of going 1 squared plus 2 plus 4 plus 9 all the way up to 18, that's going to be crazy. You take your sum of squares, right, which is here, the sum of squares, right, because I'm squaring it, and I just take the 18 to this. Like what this is saying is this: n squared. 1 is 1. All the way up to 18, 2, 3, 4, 5, 6. This will be crazy. 7. 2 squared is 4. 3 squared is 9. 4 squared is 16. 25, 36, 49. And you got to add all of those up all the way up to 18. But instead, what you can do is just go n times n plus 1 times 2n plus 1 divided by 6, which would be 18 times 18 plus 1 times 2 times 18 plus 1, 2 times 18 plus 1, all over 6. Okay. So it's 18. Put it here. It's 18 times 19 times 36 plus 1 is 37 divided by 6, whatever that is. And that'll be your answer. 18 times 19 times 37 divided by 6. We get 2,109. And that's it. Instead of adding them all up. Okay. Are there any questions? Okay. If there are no questions, make sure you check your understandings, or else you're going to get a 0 on them if you haven't done them. Otherwise, I will let you guys go. If you have questions you need to ask me on this is a lot, you can stay and ask me, okay? I'll see you later. Stay and ask me if you have any open questions. We can go over a little bit tomorrow, but we covered most of it. Bye, John. Bye, Jalen. Bye, Gianna. Bye, Anna. Yes, question.
Is tonight's homework only 3 through 29 odd?
Yep. And then
Alright.
tomorrow's, and you can do them all tonight if you want, but just you won't turn it in. But tomorrow, the 3 through 29 is due. I want that done. Got it? Okay.
I have a question.
Yes, Natalia.
For the sum of the positive integers, is it divided by 2 or divided by 1 for the equation?
Divide by 2.
Okay.
Do you want, I can show you. Do you need to see?
No, it's just that I wrote down 1, and then for number 49, it was divided by 2.
Yeah, it's probably my hand. It's this one right here. That's a 2.
Okay.
All right, cool. All right, Eric.
Question.
Yeah, what's up?
Do you mark me?
Wait, is it?
Isaac. Yeah. Did you mark me?
Wait, I don't even see you on my screen. I just see you talking. That's weird. Oh, there you are. Okay, because I can't see your face. That's what's confusing me. It's just a black screen. Isaac, you want to know if I marked you absent?
Yeah, because I didn't. I came a little late, and I don't know if you marked me or not.
I can't remember.
Yeah, I had the
I
same
did.
question.
I marked you absent. Eric?
I had the same question.
Okay. I marked you both absent. I marked you both here.
Okay, thank you.
All right. I'll see you tomorrow.
All right, bye.
Okay, bye.